Alrighty, I'm planning to do the biweekly contest from last Saturday, biweekly contest 75. Alrighty, here we go. Oops, I open these guys up. Okay, min plus number. A bit flip of a number x is choosing a bit in binary representation of x and flipping it. Okay, 0, 1, 1, 0. Okay. I flip the first bit. Yeah. Okay. Given two integers, return the minimum bit flips from goal, start to goal. Just whichever bits are not in common. Right. So start and goal. Just call it A and B. How about maybe X and Y? Oop. Let's do that. X, Y. Cost equals 0. Return the cost. For I in 0 to 31 inclusive, if X and 1 shift left by I. Does that work? X and I think 1 shift left by I. And let's do this. Our A equals this guy. If X bit set, and then var B equals if Y's bit is set. And then if A XOR B, I guess, right? Cost plus equals A XOR B. I think that works. Let's see. Uh-oh. Well, maybe it is and. Is that right? I don't know. Kotlin's kind of weird with bits. It's yeah, XOR. Oop. Expecting 3. 13, holy cow. One shift left by I. That does look right, so let me just print this real quick. I, A, B. And so it should just be 3. So, but it needs to be if A XOR B does not equal 0, then cost plus equals 1 else 0. Right, so that is correct then, I think. Right, and then the other one should be 2. Okay, that looks right. Okay, so my arithmetic was a little bit off. Do the other test case. So it should be 3 and 2. Or no, it's 3 and 3, right? 3 and 3. Okay, looks good. Okay, that's cool. Let's do the same in JavaScript, Python 3, Rust, and C++, and then we'll move on. Keep track of where we're at so it doesn't take long. It should only take more than a minute. All right, so call that guy X, call that guy Y. Cost is 0, return the cost in the end. Oh, you know what? This is kind of cool. We can actually do this in a one-liner. Let's do this. Well, we'll do a one-liner next. Hold on. Okay, so for let I equals 0, I is less than or equal less than 32, non-inclusive, plus I. Okay, let A equal X and 1 shift left by I. B equals Y. 1 shift left by I. And then if A XOR B, let's see, cost plus equals let's see, A XOR B question mark 1 otherwise 0. Okay, that looks good. Boom, bam, and then let's do the one-liner real quick. Okay, so then we're gonna do an array of 32.keys, not inclusive, 0 to 31. We'll map it to, right, each ith value will be this guy, XOR that guy. Let's see, filter, and then dot length. XOR that or that dot length. Looks good. Okay, so then we do that one-liner in Kotlin too. Might as well, right? I think it'll look cool. Let's see, class solution. Okay, var min bit flips equals x the integer, y is an integer, and then it's going to return int array sub 32 of it dot filter this guy, that guy, XOR this guy, dot length. Uh-oh. Boolean is expected. It's not equal 0. Oh, doesn't know it. Oh, size. Looks good. Looks good. Okay, yeah, it's kind of a fun one-liner. Let's do it in Python. X, Y, for I in range 32. If the to A equals X and 1 shifted left by I, B equals Y and 1 shifted left by I. If A XOR B, then count plus equals 1. If, oops, plus equals 0, count. Or I wasn't calling count, I was calling cost, right? Might as well call it the same thing. Cost, and then is it, what's going on here? Missing 1 count. Oh, need to give it a default value. That doesn't look right. Zero and 0. Print I A B. That does not look right at all. Is it ampersand? I forget. It would just be an ampersand. Oh, there it goes. Okay, that looks good. Okay, let's do this as a one-liner real quick. Class solution. F min bit flips. Oh, how should I want this to be? This guy equals lambda self x y, and we'll return the length of I for I in range 32 if this guy XOR Y and that guy. No attributes, min bit flips with the S. Looks good. All right. Okay, and then let's do C++, X, Y, do our cost, turn the cost at the end. All right, for auto I 0, I is less than 32, non-inclusive, auto A, X, and 1 should be left by I, B equals Y and 1 should be left by I, cost plus equals X, XOR Y, 0, really, that's not right, 32. Oh, oops. A XOR B is what I want. Looks good. Okay, and then wonder if I can do this functionally. Yeah, C++ might be missing out on the functional bandwagon. All right, let's just post our solutions here. Oh, actually, let's do this in Rust real quick. X, Y, let mute cost equal 0, cost in the end, or I in 0, dot 32 non-inclusive. Let A equals X and 1 should be left by I. Let B equals Y. Oops. And 1 should be left by I. If A XOR B does not equal 0, then cost equals 1. Okay, that's good. Looks good. Looks good. Okay. And then let's do this functionally. I wonder. Yeah, I don't think Rust will let me do a closure the way that Kotlin does. But I think I can do this functionally. I think I can do this. Let's do this. Let's try. Return. Oops. I want to return that. Hold on. Get rid of everything else. But return 0 to 32 non-inclusive dot iter dot filter x and see it or just I is fine, right? 1 should be left by I. Oops. X and XOR Y and 1 should be left by I equals 0 dot length. And I think we can just get rid of this as well. Let's see. Nope. Method not found. Range integer. Iter. No method iter in range. Oh, I wonder if I can just do this. Just filter that range. Okay. Well, I don't know how to do this in Rust. Just post it as is. Let's see. A few solutions. Okay, so what's the game plan? We are, I guess, yeah. Consider each ith bit from 0 to 31 inclusive, and increment the cost whenever the bits differ. All right, that was good. One-liners, Kotlin, JavaScript, Python 3. All right, then verbose, solutions. All right, one-liner, solutions. Alrighty, I'll copy and paste these guys in here. Go in, JavaScript, Python 3, Rust, C++. Okay. Rust, C++, play Rust and C++. They're more procedural. Python 3 is super cool. Python 3, you get a verbose solution, and Python 3 also gets a cool one-liner. Comment that out. It's cool. No, actually, I think I could clean up this one-liner a little bit. Hey, let's see. It's okay, whatever. Doesn't need to be perfect. JavaScript. Oh, this is PM. Oops. JavaScript. Kotlin. Okay, so Kotlin gets a cool one-liner and a verbose solution. Okay, looks good. Kotlin, JavaScript, Python 3, Kotlin, JavaScript, Python 3, Rust, C++, cool. All right, on to question 2. We have 1 hour, 11 minutes left. Okay. 1 hour, 11 minutes left. Here we go. You're going to zero index integer arrays where num sub I is 0 through 9 inclusive. Okay, so n equals 1 is our base case. Otherwise, we can do some reductions, it looks like. So otherwise, create a new zeros in the array. Okay, 1 less than the previous one for each index, 0 to n minus 1 non-inclusive. So 0 to n minus 2 inclusive. Assign the value this, that plus that modulus 10. Okay. That class, modulus 10. Okay, yeah, so we should be able to just do what it says, right? Got 1,000. It should be okay. Yeah, do previous and current. Build current from previous, right? One row at a time. Triangle sum. Okay, so it's a recursive function. So if a dot size is equal to 1, then return a sub 0. It's been completely reduced. Right, otherwise, we're going to create our n equals a dot size, and for I in 0 to n minus 2 inclusive, we're going to build b basically. Var b equals int array n minus 1. Okay, this isn't very efficient, but whatever, it's a good first step. B sub I equals a sub I plus a sub I plus 1 modulus 10. Return b. Oops, triangle sum b. Okay, so this one should be 8, the other one should be 5. Okay. And that's that. So I wonder, whatever. I mean, there's probably a better way to do it, like a more efficient way of doing this, but and recursion seems like it works, right? Whatever. It'd be nice to have a little bit more time to get to the last question anyhow, because I hardly ever get to that thing. Right, I do this in like 5 different languages and I can run out of time. So let's just go, right? Okay, so if a dot length is equal to 1, return a sub 0. Otherwise, let n equal a dot length. Oops, let's do this. Shorten this up a little bit. If n is 1, then that. Otherwise, let b equals array sub n minus 1. Fill at 0. Oh, I just don't need to fill it, but whatever. Return b. Doesn't hurt, maybe. Or let I equal 0. I is less than or equal to n minus 2. I, b sub I equals a sub I. A sub I plus 1, modulus 10. Return this guy, sub b, right? And it'll bottom out. Recursive function will unwind and accumulate the sum. Okay, Python, if length, oops, hold on, n equals length a, if n is equal to 1, return a sub 0, otherwise b equals 0 times n minus 1, return self dot triangular sum b for I in range n minus 1 non-inclusive. B sub I equals a sub I plus a sub I plus 1 modulus 10. Okay, looks good. Running, okay. Python, C++, oops, vector of integers. Okay, n equals a dot size. If n is equal to 0, return a sub 0, otherwise b sub n minus 1. Return triangular sums b for I 0, I is less than or equal to n minus 2 inclusive. E sub I equals a sub I plus a sub I plus 1 modulus 10. Boom. There we go. Okay, let's post this. Few solutions. Oh, I haven't seen this dude post in a while. Steve Poochman guy. That's cool. I'd love to see him participate in contests. He usually posts some pretty awesome solutions. Python 3. Rust. C++. All right, I just wrote in C++. Python 3. Make this bigger. JavaScript. Kotlin. I guess I don't need the squigglies around this guy. It's still cool, right? Yeah. A little bit shorter. Okay, do the Rust and then move on. Let's see, where's Rust? Rust. A type vi goes back I32. Okay, if, let's see, let n equals a dot length. If n is equal to 1, turn a sub 0. Otherwise, let mutable b equal a vector of size n minus 1 filled with 0. Turn triangular sums b for in 0 until n minus 1 non-inclusive. B sub I equals a sub I plus a sub I plus 1 modulus 10. Oops. Cannot find function in this scope. Triangular. Did I mistype it? No. Huh. Wonder Rust class recursive function. Is it a possible recursive functions? Yeah, I want a recursive. Recurs. I can. New line kind of sucks. Doesn't help. Let's see. Rest class invoke method. Method call expressions. Oh, do I need an ampersand self? Where this works? Self. Self dot. Takes 2 arguments, but 1 was supplied. Oh, that's self. I have no idea what I'm doing here. I thought that Rust could, how to call method inside Rust class. How to call a private method. It's passing this a reference. What? I'm going to test private methods in Rust. Huh. Yeah, I'm still learning Rust, so I don't even know how to invoke a function properly. Okay. Well, it'll be what to do. That's cool, whatever. See, Rust is to do. Implement me. Okay, that's cool. Yeah, 4 out of 5 languages isn't bad, right? That's cool. All right, Kotlin, JavaScript, Python 3, C++. Oops. Oh, I forgot to write a description. I guess naive recursive solutions, which reduce the input array A. It's fine. Okay, and how much time we have left? We have 59 minutes. Okay. 59 minutes left. Left in the contest. Okay, here we go. Q3. Time to shine. Okay, so we got two different types. We have office and restaurant. No consecutive buildings can be selected of the same type. It is silly official. You want to select 3. You can't select them right next to each other the same type though. Okay, return the number of valid ways to select 3 buildings. So, okay, this is a counting type thing. So we cannot select the 3rd, 5th, 1st, 3rd, or 5th buildings. As that would form 0, 1, 1, which is not allowed due to having 2 consecutive buildings of the same type. Okay, so we're basically looking for how many 0, 1, 0s we can find and how many 1, 0, 1s we can find, right? We are counting the amount of substrings within S, which can be either 1 or 0, 1, 0 or 1, 0, 1, right? This is case 1, case 2. Okay, and it's a long, so this thing's pretty big. 185, so we're looking for a linear time solution. Okay, so how are we going to come up with this? Let's see, come up with this explanation. See what makes sense and keep it simple. Okay, so here we're saying 0, 1, 2, 3, 4, 5, 6, n equals 6. So we're saying 0, 0, 2, 4. So it says 0, it's basically 1 or 0, 1, 0. And then we're saying 0, 3, 4. 0, 3, 4, right? Which is also 0, 1, 0. Oops, 0, 1, 0. 0, 1, 0. And we're saying 1, 2, 4, which is 0, 1, 0. 2, 4, 5, which is the same as 1, 0, 1. And then 3, 4, 5, right? Okay, yeah. 3, 4, 5. 1, 0, 1. So we should be able to do a linear scan and then count the state that we're in, right? For the first one, and then the state that we're in for the second one, right? With 0, and then so how many zeros we have before the ones we have before the zeros? Right here we have 1, 2 zeros before we have 1, 2 ones, and then we have one more and one more. Right? Should it be 4? No, is it 6? 1, 2. So okay, I'm not counting it right. It's 1, 2, 3, 4. Oh, I'm missing one. Hold on. 0, 2, 4. 0, 3, 4. 1, 2, 4. 2, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5, 6. Which one am I missing? What the heck is this? 1, 2, 3, 4, 5. Oh, I'm missing 1, 3, 4. This is 1, 2, 4, 1, 3, 4. 1, 3, 4. 0, 1, 0. So it should be 2 times 2 for the first one. Times, right? So 0, 1, 0 comes out to this. 2 times 2 times 1. Right? There's 4 of those. 1, 0, 1 comes out to how many ones do we have before zeros before ones? 2 times 1 times 1, right? So then that makes sense, right? It's 4 plus 2 is 6, right? 4, 2, right? 4 plus 2 is 6. Okay, so that makes sense then. That's the game plan. We should be able to implement that pretty quick, I think, right? Count the number of zeros for the number of ones for the number of zeros. All right, so we should be able to, do we need to pre-process that then, right? So count to 0, and when we get to a 1, I wonder if we can use a bucket of 3, A, B, C, 0, 1, 0, 1, 0, 1. This times that times that. Count of zeros to the left, ones to the left. Yeah, so this, maybe it's not quite as naive as I was thinking. Like 1, 0. I guess there's another 0 over here to count for that other one. Okay. I think I'm confusing myself, but I need to remember to keep it simple, right? This is not too terribly difficult, but remember, keep it super simple. What if each of those ones is a pivot? Yeah, I think that makes sense. Okay. What if each string was a pivot? Right, so if we have 0 and 0, then the pivot would be 1. I multiply the amount of zeros to the left and multiply and accumulate the amount of zeros to the left and the amount of zeros to the right. I think that would work out, right? So we pre-process the input here for this guy. This is S. These are indices. 1, 2, 3, 4, 5, 6. And this would be L, R. Okay, so the zeros to the left would be 1, 2, 2, 2, 3, 3. Zeros to the right would be, let's see, 0, 1, 1, 1, 2, 3. Okay, if we're doing 1, 0, 1, then we're going to go 2, 2, 2, 2, 2, 2. Okay, here's our first one. How many zeros are to the left of this guy? There's 2 to the left. How many zeros is the right? 2 to the right, or 1 to the right. So, okay. 2 times 1 is 2. And here, how many 2s are to the left? There's 2 to the left, 1 to the right. 2 times 1 is 2. And that counts that pattern. So then we'll do the opposite for the other pattern. How many 1s are to the left? How many 1s are to the right? Okay. So let's just write a generic function which takes a target and performs a running some linear scan in each direction, right, left to right, and right to left. Then perform a linear scan to accumulate the products of the targets, right? To the left and to the right. Okay, I think that makes sense, right? So rn equals the s.length. And a number of ways will be our count. So our count equals 0 and it's a long. Turn the count in the end. And we're going to do function of f. And we're going to take in our target. Target to be a character. So I'll turn the long. Let's go R. So actually, let's return this. Return f. So our target would be 0 plus f. So target would be 1. Turn the count. All right. Then let's see how far. Now it goes int array. So in 0 bar r is int okay. Also 0, and then L sub 0 equals if S sub 0 is equal to our target 1, otherwise 0, and then R sub n minus 1 equals if S sub n minus 1 is equal to target 1, else 0, for I n 1 until n, L sub I equals L sub I plus 1 plus if S sub I is equal to target 1, otherwise 0. Same thing for R, for I n minus 2 down to 0 inclusive R sub I equals R sub, minus 1. R sub I plus 1 plus F sub I equals T 1 otherwise 0. Then for I n 1 until n minus 1, non-inclusive, count plus equals L sub I multiplied by R sub I. Okay, and that should be 6. Unresolved reference char. Oh. 20, uh-oh. That doesn't look right. Oh, wait. If S sub I does not equal the target, right? That means the pivot. 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 Okay, that looks right. Okay, and then 0 for the other one. Okay, looks good. Yay, okay, that looks legit. So let's write this real quick in the other languages and then move on. Okay. Okay, our target will be this guy. Oops. Okay, so basically the same thing, right? So let F equal target, then count, turn our count in the end, and we're going to do, let's do this. N equals s.length. Okay, and so let's L equal array sub n, fill 0, R equals array sub n dot fill 0, oops, array. And then let I equal 1. Okay, L sub 0 equals number S sub 0 is equal to target. Similarly, R sub n minus 1 equals number S sub n minus 1 equals the target. Minus n L sub I equals L sub I plus 1 plus number S sub I equals T. And then do the same thing for R, n minus 2 down to 0. R sub I, oops, this needs to be to the left. equals r sub I plus 1 plus number sub I plus t. Alrighty, and then oops, hold on. Let's actually accumulate the count of the products. So for let I equal 1, I is less than n minus 1 plus I, and then if S sub I does not equal our target, and this is our pivot, I'm going to do count plus equals L sub I times R sub I. Okay, that looks good. Okay, looks good. Looks good. On 3. Def F target turn count that that turn F target will be see 0 plus F 1 and so L equals 0 times n, R equals 0 times n, and then for L sub 0 equals int S sub 0 is equal to target, for I in range 1 to n non-inclusive, L sub I is L sub I minus 1 plus S sub I is equal to target. And then R sub n minus 1 is equal to S sub n minus 1 is equal to our target. For I in range n minus 2 inclusive down to -1 non-inclusive, R sub I is equal to R sub I plus 1 plus int sub I is equal to our target. And then for I in range 1 to n minus 1 non-inclusive, if or let's just return this actually. Return the sum of L sub I times R sub I for I in range 1 to n minus 1 inclusive if S sub I is not equal to t. That's our pivot. Looks good. It took a little while. Okay, looks good. Let's do this in C++. Long. Auto F equals capture S by reference. Turn F sub 0, F sub 1. Count 0. Turn the count to the end. For how to let's see. Okay, FBI, vector of integers. PI L sub 10 equals size in R in L sub 0 equals sub 0 t times 1 to n non-inclusive. L sub I equals L sub I minus 1 plus sub I plus t. R sub n minus 1 equals sub n minus 1 is equal to our target. Go back in the opposite direction from I is n minus 2 inclusive down to 0. Sub I equals R sub I plus 1 plus sub I plus t for other I is 1 to n minus 1 non-inclusive. If S sub I is not equal to target, then count plus equals L sub I times r sub I. Okay, that looks good. 6 and 0. That's legit. It's cool. So C++, Python 3. I do it in Rust as well. Fun. Or no, FN. FS string. And now target character. Oops, character. That'll return I64. Mute count. So I64. 0. Return count. Return F sub S 0 plus F sub S 1. Okay, and then let's see. N equals S dot length. Let L equals a vector of 0, length N. R is the same thing. L sub mutable. L sub 0 equals if S sub 0 equals target. Oops, S dot chars dot nth 0 equals that guy. Oops, dot unwrap. Equals that guy, it's 1. Y is 0. For I in 1 until n non-inclusive, L sub I equals L sub I minus 1 plus if S sub I, S dot chars dot n I equals T 1, otherwise 0. R sub n minus 1 equals if S dot chars dot n minus 1 dot unwrap T, it's 1, otherwise it's 0. Just put a semicolon at the end of these things. For I n n 1 dot n in reverse. Not down to n all the way, but n minus 1. Reverse. I. R sub I plus 1 plus if S dot chars dot n. Target is 1, otherwise 0. Okay. For I in 1 to n minus 1 non-inclusive. If S sub dot chars dot n I is not equal to target. This is the pivot. Pivots. Then count plus equals L sub I times R sub I. Okay. Char. Oop. Lowercase char. Okay, what else do we got here? Expected enum. Oh, I need to unwrap the nth character. Unwrap. Unwrap the nth character. Unwrap the nth character. Move. Okay, gotta borrow it. Let's see. Borrow. 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 Looks good. Oh no, time limit exceeded. Okay, whatever. I totally want to get to Q4. I usually run out of time. So awesome. I have 30 minutes left for Q4. Okay, let me post this real quick. We'll get on to Q4. Alrighty. A few solutions. Let's see. Kotlin. JavaScript, Python 3, Rust, C++. Okay, and I just wrote it in Rust, right? This TLEs, but whatever. It's all those int unwrappings. Well, actually, you know, let's refactor this real quick, right? I can fix this up, right? Let's just do J in reverse, right? So let J equals n-1 minus I, right? And then do this dot J. Well, I don't know if this helps or not. Never mind, but we can refactor. It's fine. Let's refactor it. It's cool. It's not going to help the runtime, but it'll help with the readability. Should, I think, in theory. Semicolon, I-1, oops, minus I. There we go. Oh, that's not right. Oh, dang. Okay, so my n-1 minus I. Oh, I need to initialize R sub n-1 equals all this thing. n-1 sub J I L sub IJ. That's not right. Okay, well, whatever. That one needs some. We can fix it up, right? What's going on here? It's left, right, J. J goes this way, I goes that way. n-1 minus I. n-2. n-1. That looks right. What's wrong then? Ah, J. That J looked just like that I. Okay. All right, whatever. It is a little bit better code, okay, right? So instead of having 2 for loops, might as well just have J go in the opposite direction of I. So let's refactor this real quick, post it, and I still want to get back to Q4 real quick. So let's refactor this, right? Do this guy, that guy, and then J equals n-1 minus I. Do this guy inside here, J, opposite direction of I. Yeah, right. That's a little bit easier to read, right? It's cool. A little bit less redundant code. Looks good. Looks good. All right, let's post this, get to Q4. Oops, okay, that's good. Put that there. Okay, Python 3. Let's refactor this a little bit. J equals n-1 minus I. Stick this in here under J. Grab U. J. 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 All right, get rid of that. Looks good. Uh-oh, something's wrong. Oops, I didn't initialize J. R sub n-1 equals int. S sub n-1, it's T. Looks good, looks good. It's a little bit slow. Okay, there goes. All right, Python 3. Okay, JavaScript. We'll refactor this up a little bit and then post it. Okay. J equals n-1 minus I. Stick this, nope. Stick this there. This one here. Stick the J in there. Initialize this here. All right, get rid of that there and we're good to go. And actually, let's do this in a functional programming way. How about we can clean this up? Let's see, return low dash sum of array sub. Oh, this is going to be kind of ugly, but whatever. We want n-2 dot keys dot map I to I plus 1 dot map I to L sub I times R sub I, and take the sum of that whole thing. Okay, hold on, this is not going to be readable. Here, let's leave this here for now. Like, this works, right? Make sure this is cool. 6 and 0. Okay, and then grab this guy. And then that's kind of cool because we don't have to have a count up here even. All right, should we, oh, keys dot map. Oh, I need to, this guy, and I want that guy. There we go. 20, that's not right. Okay. Oh, that filter, right? Dot filter I, S sub I is not equal T. Dot map. Okay. Quite a bit more verbose than the Python equivalent, that's for sure. Okay. I mean, it's cool, whatever. Okay, and then Kotlin. Okay, let's factor this one, clean it up a little bit. J goes in -1 minus I. This here, there. The J in here. J moves opposite of I. Initialize R sub I here. Get rid of that there, and that's cool. Right. All right, should be good. Okay, and then clean this up a little bit. Yeah, functional programming. Right, we don't need count, which is kind of cool. Okay, so return long array n-1 or n-2 dot map it plus 1. So of it, map it to it plus 1 filter s sub it is not equal to t dot map L sub it times R sub it dot sum. And long was expected. Long array for type is int. It's not too long. Dot filter. Oh, don't listen to me. What's going on here? Type is long, but int is expected. Oh, I need to use int as an x. Wait, okay, I don't need, this needs to be an int for that, which is fine. For this to that, map that dot too long, right? Let's see, dot too long times that dot too long dot sum. I think that's okay. All right. Cool. Okay, whoa, mouse is going all crazy. Okay, so Kotlin, JavaScript, Python 3, Rust, C++, so it's cool. Okay, make a little explanation here, and then go on to Q4. Totally stoked to get to Q4. I still have some time, so let's get going. Don't waste too much time here. Okay, so compute the amount of, let's see. Consider the value in the middle as a pivot. And which we can use to pre-compute the amount of, I guess, non-pivot values to the left and to the right of each ith index from 1 to n-1 inclusive. Well, I guess we don't need that much detail of each ith index. Is probably fine, right? Right. Let the non pivot values then be our target t, which we can use, which the function f performs the pre-computations. It's fine, right? Just t, and then let the non-pivot values be our target t. Right, then we can accumulate the product of the pre-computed values. And the answer, right? Whatever. You're gonna have to think about it, right? I'm not gonna spoon feed you. C++. Right, might as well write a comment there. This is our pivot. Pivot. We can accumulate the products, right? The products of the pre-computed values is the answer. For each, I guess, pivot index. Well, right. By performing a linear scan of each pivot index. I think this makes sense. Don't overcomplicate it, right? Consider the value in the middle as a pivot, which we can use to pre-compute the amount of non-pivot values to the left and to the right of each ith index. Let the non-pivot values then be our target t. Right, return the accumulated products of the pre-computed values as our answer. Right. Let's just put an example. I guess there are two possibilities for strings which match the search criteria of the problem statement. Right, so it's 0, 1, 0, 1, 0, 1. Right, so here the pivot is 1, and the non-pivot, I guess in the target, right? The target is 0, and this one's backwards. Here the pivot is 0, and the target is 1. For example, there are two possibilities for strings, for input, for strings of length 3, which match the search criteria of the problem statement. Okay, that was good. Yeah, don't spend too much time on it, right? Let's move forward. Okay, that's that. And we have 14 minutes. Okay. Spent more than I wanted, but we do have 14 minutes left, so this is cool. This is totally cool. I usually haven't gotten this far during even virtual contests, right? Since I've been writing solutions in 5 languages. It used to slow me down a little bit more, so I am improving, but whatever, it's cool. Okay, so here we go. I got 15 minutes left. About 15 minutes left in the contest. Here we go. Oops. Okay. Prefix is a score, so given the final string, return the sum of every score. Okay, this is like dynamic programming since it's optimal. Structure with overlapping subproblems, right? This is the suffix. B is the common prefix, so that's 1. BAB is the longest common prefix. You can use like a suffix array or something like that probably for this too. This one, I guess the trick is to avoid TLE since n is 1e5, right? So since n equals 1e5, the I guess hard part is avoiding TLE. Since a naive solution, right? Naive quadratic runtime solution would definitely TLE, right? Definitely TLE. But that's a good start, right? And I'm getting pretty worn down, so something tells me I'm gonna do my best, but let's see, we got 11 minutes, let's see. I don't think this is necessarily too hard though, so let's just work on it, work through it, same as the other ones. S2, S6, S9. What? The whole thing? One, 3, 5. Yes, I mean, there certainly is a pattern here. Let's just do brute force for now, right? And then that's a good start. Right, so B is the longest common prefix. So we're looking for prefixes of size 1, prefixes of size 2, prefixes of size 3, and so on. Prefix. So as you scan the suffix backwards and reverse. Yeah, I'm trying to skip ahead. I feel like let's just do the brute force solution, and that's a good start. And there's our length. I is 0 until n. Our suffix equals to our j equals n minus 1 minus I. So j inclusive to n non-inclusive. Let's slice from j until n. Our prefix is s.slice 0 to I plus 1 non-inclusive. Count plus equals if that prefix equals suffix 1, otherwise 0. Three, no, that's not right. Oh, the score is the length. Prefix dot length. Otherwise 0. It's 9. Okay, so between 9 and 14, and then it should TLE. Okay, so this is the wrong solution. 9, and then that's 11. 2, 3, and 9. Let's do this. If suffix equals prefix, then println prefix. Let's just do this. Cost, oops, count plus equals prefix length. And oops, print lin. Okay, so that guy and then that guy, and I'm not getting the middle one then. AZ, BAZ. Right. So am I comparing these? I don't know. 7, 8, 9. Okay, so n equals 9. This is, I'm saying the prefix at I I not inclusive, I plus 1. This guy, right? And then J in not inclusive. So I would be at 0 to 6. Five. Okay, so I equals 5. I equals 5, then J equals n minus 1 minus 1 is 8 minus 5 would be 3. That is correct. So it is at 3. That is so strange. It's not equal then. Okay, so if I is equal to 5, then we'll do print len J, which is expected to be equal to 3, and then do the prefix and the suffix. Okay, let's see what's going on here. J is 3, AZ, B, AZ, B. So prepending each new character. Like what? What are you talking about prepending each character? Does it just mean right to left? It's left to right? I think so. Longest common prefix between them. Oh, longest. Okay, so they're not exactly the same, but they do have a common prefix between them. I see. Okay. So we'll walk each of them. Right. Okay. While. Let's do K 0, right? Oops. K equals 0. While K is less than equal to I. It's K. And prefix sub K equals suffix sub K. Count is plus plus. Right, plus K and then plus count. Okay, 9 and 14. Okay, so that's cool. Right, so this should TLE. And then how much time do we have left? 1 minute, 53 seconds. That's not too shabby. TLE, right? Okay. Expected to TLE, and it does. Okay. Okay, well, we don't need that detail, but that's cool. And go back. Okay, yeah, so that's a good start. And we'll fix her up. Okay, cool. Right. Okay, cool. Good start. And let's take a break. Fix it up. All right, cool. Yeah. Thanks for watching. Cheers. Oh, whew. Let's see. Beers on. Cheers. Oh. What's going on with this thing? My Zoom's weird. Okay, here we go. Oh, my emojis aren't coming up. What the heck's going on? All right. I think it's just really not liking this. It's really not want to let me push an emoji on here. What is going on? Okay, whatever. See you next time.